Hello, students. I'm here today to do some chemistry things for you. I got some requests to do a couple more practice problems, so I thought, why not? Let's look at right here to start. So I have a problem here, multiple problems actually. Got my mole roadmap up here. I've got my equation right here, and I've got 1, 2, 3 problems that we'll do. So the first one says, if you have 49 grams of lithium hydroxide, how many moles of H2O will you produce? Well, we have to do a couple of things before we start this problem. First, we have to make sure that our equation is balanced. So we look up here and we start to do some balancing. We got Li, OH, H, and CO3. And then over here, we're like, well, I don't have an OH or an H. I have an H2O. And then we remember, oh, I could rewrite this H2O as HOH. Now I have an H and an OH, so I'm all good. So I've got 1, 1, 2, 1. Over here, I've got 2, 1, 1, 1. We're going to put a 2 in front of this, so this makes this a 2 and this a 2, so then we're going to put a 2 in front of that. Now we've got a balanced equation. So 2 lithium hydroxides plus carbonic acid makes water and lithium carbonate. Okay, so that's the first place we got to start. We always have to balance the equation first. So our ratio is 2 to 1 goes to 2 to 1 of the other items, the other substances. So it says if you have 49 grams of lithium hydroxide, how many moles of H2O are you getting? Okay, so for this one, we're trying to go from grams of one substance to moles of another. So we're going to start right here in the mass in grams. So I'm going to put 49 grams of LiOH, and my goal is moles of H2O. Okay. So I'm going from here into here. So I'm following this line. So that tells me I need to say times 1 mole over the molar mass. So I look up the molar mass of LiOH, get my periodic table here. Lithium is 6.94, oxygen is 16, so that's 22.94, hydrogen is 1.01, so that's 23.95. So I get a total of 23.95 is my molar mass. If you need a minute to figure that out, take your time when you do it. I'm just doing it as quickly as I can here. So grams and grams will cancel out. So now I'm in moles. Okay, but I don't have the right substance. I've got lithium hydroxide, and I'm supposed to have H2O. So that's where I have to use this mole ratio. Okay, so I'm going to use the mole ratio here. And now my mole ratio, there are 2 waters for every 2 lithium hydroxides. So what we're going to do is we're going to say times 2 H2O or HOH, whatever we want to call it. We have 2 of those for every 2 LiOH. So that will allow us to cancel out our LiOH, and what we're left with is moles of H2O. Now we go to our calculator. Whoops, that wasn't intentional. Calculator. And we put 49 times 1 divided by 29.34. I'll move this out of the way so it's there, times 2 divided by 2 equals. And it gives us 1.6700. And we look here, we've got 2 sig figs, so I would just say there's 1.7 moles of H2O. All right, so that's an equation where you're going from grams of one substance to moles of a different substance. Okay, the next one's a little different. The next one, I'm going to erase what I got here just so when I draw the arrows, it'll be a little clearer. The next one, I'll even change colors. We'll use black this time. So it says, if you have 2.17 moles of H2CO3, how many grams of Li2CO3 will you produce? So now we're going from moles of one substance to grams of a different substance. So we start by putting what we know, 2.17 moles of H2CO3. So that's what we know. And what we want to know in the end is grams of Li2CO3, of lithium carbonate. Okay? So we're here and we want to go to here. Okay? So in order to do that, well, if we're changing substances, we always have to use our mole ratio. Earlier in the year, when we were going from grams to moles or moles to grams of the same substance, we just ignored that because the mole ratio is always 1/1 because it's the same substance, right? If we're wondering about moles of H2CO3 to grams of H2CO3, well, H2CO3 has a 1 for its coefficient, and it'd just be 1/1. We wouldn't have to worry about it. Now we have different substances, so we have to use that mole ratio. So 2.17, so I'm going to say times, now I'm going to put the mole ratio next. So this is, I want to know lithium carbonate, so Li2CO3, that's my substance. I look up here, it's got a 1 in front of it, so I'm just going to put a 1 there. The hydrogen, or the carbonic acid, H2CO3, there's a 1 there too. It's not going to end up changing anything. So those cancel out. Now we need to go out to the mass in grams. So I'm going to do a little step here where I figure out the molar mass because I want to know the molar mass over 1 mole. So I put a grams over 1 mole, and I need to find the molar mass of Li2CO3. Well, lithium is 6.94, and there are times 2, plus carbon is 12.01, plus oxygen is 16 times 3. So there's my molar mass is 73.89 grams. So 73.89 grams. All right, there's my molar mass, and that cancels out my moles. So now I say 2.17, over a little bit, 2.17 times 1 divided by 1. Now I know 1 divided by 1 doesn't do anything, but I'm doing it because I have a system for doing my problems, and that's the important thing, is having a system, having a systematic way that you always work through things, because then you won't screw up. Because if you just do them the same way every time, you're not going to make any mistakes. Okay, so even though 1/1 is nothing, is just 1, I'm just going to put it in there anyway, and then I do times 73.89. That's my grams, and that wasn't right because something screwed up. All right, 2.17 times 1/1 times 73.8. This will be better. All right, 160.3413. I got 3 sig figs, so I can just say 160, and I'll put a dot at the end to say that that is the known number. Okay. All right, that's 2 of the 3. All right, last one. Let me erase here real quick. All right, and I'm going to do one more. I'll use the sparkly pen this time. All right, it says, if you have 128 grams of H2CO3, how many grams of H2O will you produce? So I'm starting with this guy, and I'm going to this one, okay? So start with 128 grams of H2CO3. So I'm here in mass in grams. I need to go into moles, okay? Then I need to use my mole ratio to go back to mass in grams, because my grams, I'm still using the grams unit, but these don't, the number of moles of H2CO3 and the number of moles of H2O are different. So we have to be able to go into moles first and then come back out. Because remember, moles is what allows us to convert from one substance to another, okay? And knowing the balanced equation. All right, so times 1 mole over the molar mass. H2CO3, I'll do a quick calculation, 1.01 times 2 plus 12.01 for the C plus 16 times 3 equals 62.03 grams per mole. So I'll put that in there. times, now I need to do my mole ratio because I have gotten rid of grams. Now I'm at moles, and moles is our key. So now I use my mole ratio. So I say, all right, there are 2 H2Os for every 1 H2CO3. We know that because that's our balanced equation. There's 2 H2Os for every 1 H2CO3. Okay. For those of you who did your recipes, this is like if we change our recipe, or if we do our recipe and we change the amount of one substance, we have to change the amount of the other substances. Okay. Times, and then I've got the molar mass. I'm going from mole ratio out to mass in grams. So I'm going to use the molar mass of H2O. I always use the molar mass of the substance directly to the left of my of where the molar mass is. Okay, just like right here, I was using the H2CO3's molar mass. All right, water 18.02. That should be memorized over 1 mole. So cancel, cancel. We go 128 times 1 divided by 62.03 times 2 divided by 1 times 18.02 divided by 1 equals, oh, that's off the side. Lots of decimals. 74.36917. We've got 3 sig figs there for our 128. So we would just say 74.3. The 6 rounds it up, so it becomes 74.4 grams. All right. I hope that this is helpful to you. Remember, every time you go into the center, every time you go to moles, you're going to have to use the mole ratio. Okay? Every time. So from now until the rest of the year, you're going to have to do that. All right. I hope this helps, and I will talk to you another time.